Hello, the purpose of this video is to show how to process AHP data which have been collected from many respondents. In fact, in research, those researchers who are using AHP in social science research, it is very common to collect data from multiple respondents. Now, how these multiple respondents data to be averaged out so that the average pairwise comparison matrix is dealt with. Professor Thomas Sati, who developed analytic hierarchy process, justified to use geometric mean method to compute the average pairwise comparison matrix. There are basically two ways to collect AHP data, either by interview or by questionnaire survey. So please let me share the screen to show the further demo. Now, if you are using, if you are interviewing your respondents, then please make sure that you collect data at the very first place, the demographic information, because you need to provide demographic information in your write-up. So do not forget to collect the demographic information, even though you are interviewing your respondents. Now, since you are interviewing, and you will be writing the responses by yourself, so you can prepare a pairwise comparison matrix like this. So in this case, there are 6 criteria which are arranged as per the norm for AHP in the column, first column, and also first row. Now, you have started your interview for the first respondents, and you will be asking between C1 and C2. Of course, they have to know what is C1, C2. Which one is more important and how much more. And then you will be writing the response yourself. So the response could be less than 1, could be more than 1. Similarly, between C1 and C3, which one is more important and how much more. And so in this way, you will be completing all the responses. But please note that this is for only one respondent. If you have multiple respondents, that sample size could be 5, could be 30, could be 50, whatever. It depends upon the scope of your research. So if your sample size is 30, then you will be having 30 pairwise comparison matrices like this. And then you have to compute the geometric mean to get the average pairwise comparison matrix. But there are occasions where people are not available for interview. In that case, you have to develop a questionnaire like this. And then you will be sending this questionnaire to the respondent, and then respondents will be completing, and then you will get back. But again, you have to be careful about to collect the respondents' demographic information like this. And then since it is not interview, it is the questionnaire survey. So you have to provide the details about your factors which you are going to compare with the help of your respondents. So in this case, in this matrix, in this demo, please note that there are 5 sub-qual items like tangible, reliability, etc. And my intention was to get the comparison with the help of the respondents. So as you see that this is already filled up matrix by one respondent. So tangible versus reliability. So in this case, it is 5 in favor of reliability. That means the respondent perceives that reliability is strongly more important compared to tangibles. Similarly, here also responsiveness strongly more important than tangibles. So in this way, the respondents will be completing this questionnaire, and this will be from many respondents, as many as your sample size as you plan for. Now at the end, you need to compute the geometric mean from all the responses. Now, after computing geometric mean, then you will be using software. In this case, there are many software available, including Excel. Non-Excel, there are 2 very widely used. One of them is expert choice, and other one is super decision. Expert choice, it has functionality to compute the geometric mean by itself. So you don't have to compute geometric mean manually, it can compute by itself. So what you need to do, you need to just key in the data, individual responses data, and it will compute automatically. But if you are using super decision, which does not have the feature to compute the geometric mean by itself, so in that particular case, you need to compute the geometric mean manually, and you can do it using Excel. So if you are using Excel to compute the geometric mean, then this is the process. Let me explain. Here, you need to put the first comparison. In short, I have put here C1, C2, that means the first comparison, pairwise comparison. Then C1, C3, C1, C4, C1, C5, C1, C6. Please note that here, in this case, there are 6 factors. So this one, C1, C2, C1, C3, C1, C4, C1, C5, C1 versus C6. And then C2 versus C3, C2 versus C4, C2 versus C5, etc. Now in Excel, you have to complete, or you have to write all the comparisons here in one particular row. So C1 versus C2, C1 versus C3, C1, C4, C1, C5, C1, C6. And then it starts with C2, C3, C2, C4, C2, C5, C2, C6. And then again, C3, C4, C3, C5, C3, C6, C4, C5, C4, C6, and C5, C6. And this is the responses of the first respondent. It could be interview data, it could be questionnaire data. So the first respondent has entered 1, has given 1 for C1, that means they are equally important. Here, the first respondent perceives that C1 is strongly more important than C3, and so on. So this is your first respondent data. So you key in the first respondent data. Please note that all pairwise comparisons to be written like this. Then you come to the second respondent. Second respondent data are like this. So you key in the second respondent, third respondent, fourth respondent, fifth respondent, as many respondent as you have. In this demo, I have considered only 3 respondents, but it can be 30, it can be 50, whatever. And once you complete your data, I will show you another file of similar type, which I used AHP for one of my research, and then I computed the geometric mean using Excel. But in this case, sample size was quite large, 116. 116 was the sample size. So if you have sample size large, then the Excel file will look like this. And these are the comparisons. I did not put C1, C2, I just put A, B, C. I just use that A means the first comparison, B means the second comparison, C means third comparison, D means the fourth comparison, etc. Now, in this case, I just will be explaining only for 3. And then the crux of the thing is that you have to compute the geometric mean. So in Excel, geometric mean formula is like equal to sign geo mean and the cell address. The first one is A2, and in this case, the last one is A4. So then the moment you click enter key, then you will get automatically 1.14. Similarly here, you can just copy the cell address and then enter, then all the geometric means will be computed by Excel. Then after that, you need to compile. You need to compile all this into your actual pairwise comparison matrix. So in this case, C1 versus C2 is 1.14, C1, C3, C 3.41, then C1, C4 is 4.12, then C1, C5, C1, C6. This one is C2, C3. C2, C3 is here, directly here. Then C2, C4 is here. C2, C5 is here. C2, C6 is here. Then 3.91 is here. All right. Now, in this case, you please note there are 2 values which are less than 1. It does not matter. It can come any value less than 1 or more than 1. actually depends upon the respondents. So we already got the geometric mean pairwise comparison matrix. So in this case, I have taken sample size 3, but in case it can be 30, it can be 50, it can be more than 100. Whatever it is, at the end, you will get a pairwise comparison matrix like this. Then you have to come to super decision software to key in this data. So super decision software will be like this. I already, for this demo, I already created this simple hierarchy where the first level is the goal, that is always the case, and second level consists of the 6 criteria, and I have already linked. Now the time to key in the data, so we have to click Assess Compare, then Pairwise Comparisons. Now for AHP super decision software, there are 5 ways we can key in the data: graphical, verbal, matrix, questionnaire, and direct. Please note that for this geometric mean computation, we need to use this matrix mode. Matrix mode. So to save time, I have already keyed in the data 1.14, 3.41, as you see here. You see here 1.14, 3.41, 4.12 is the same data. Okay, and also please note that when initially when you will delete here, when you start key in the data, it will be 0. It will be 0. Let me write it down. Okay. Initially it was 0. This one. So when it is 0, then you just need to put, what is the number here? Number here is 0.54. So you just key in the value 0.54, and then you bring the cursor somewhere else. It will be automatically 1.85 red color. Red color means it is a reciprocal. So you don't have to worry whether it is less than 0 or less than 1 or more than 1. So you can just key in the data as it is. For example, this one is how much? This one is sorry, this Excel. This one is 0.66. So 0.66. So you need to just enter 0.66 and then bring the cursor somewhere else. It will be automatically red colored 1.51. That's it. So once you enter the geometric mean data, which you are transferring the values from the Excel to super decision, the priorities are automatically computed. So these are the priorities. The first one 0.29, second one 0.32, for C3 is 0.12, C4 0.05, C5 is 0.11, C6 is 0.84. So these are the actual priorities which I got from 3 respondents. So that as I mentioned many times, your sample size could be 3, could be 30, could be more than 100. At the end, you will get the priorities in this column. And also don't forget to check the inconsistency amount, which is here 0.03. This ratio should be less than 0.1. Then the amount of inconsistency is acceptable. So briefly, this is the way to compute the average priorities from the geometric mean pairwise comparison matrix. So in summary, what you need to do, you complete your questionnaire survey or interview, then make the individual data ready, then key in this data using Microsoft Excel, as I showed here, like this. Obtain the geometric means, then from this pairwise comparison matrix, key in this data in the super decision software using matrix mode. Once you complete the matrix entry, the entry of the data, then you will see on the right the priorities all there. So I hope that this video is useful to process your multiple respondents data. Thank you very much for watching.